All right, so, okay. Now, when you are charged interest, there's two types of ways that's done. One is called simple interest. The other is called compound interest. Usually when you get a car and you get the car financed and you pay per month to pay off the loan, that's usually simple interest. I say usually, but I'm pretty sure almost all the time. Every time I've gotten a car and I've gotten a loan, it's always been simple interest. Now, here you take the principal, which is the amount of the loan, the P, you multiply the rate, which would be the decimal percent, and then you multiply the time, straightforward. And that becomes the interest. We're going to have an example in a minute. So you get your interest by doing this calculation, and then you add that to the loan, and that's the total amount you have to pay back. And it's called simple interest because there's no exponents. We don't have to think of a growth factor at all. Now, when you have compound interest, that's where you have your growth factor based upon 1 plus the decimal percent, just like with the warm-up. When I created that for the number 2 and 3 problem. The P here would be the original amount you're starting with, and then the amount you have over time, whether that's increasing or decreasing. So you can have a negative rate. Now these two formulas are really the same. Okay, they may look different, but the exponent is always based upon time, and the rate is always based upon the rate per unit of time. So if you decided to do this 4 times per year, then you divide the interest by 4 to get the rate every 3 months. And then in 1 year, you would have 4 intervals of time. If you decide to do this every month, then the interest would be divided by 12 to get the rate per month, and then you'd have 12 months in a year. So just think of this as the rate based upon the time. So we might have to divide the per year to get a due rate per time, and the exponent is always based upon however many time units there are. Okay, and notice these are exponential. So, applying these formulas real quick, and then after this, I think we'll take a break. All right, so again, just like the warm-up, here we had our 1 plus 0.01, okay? And in this problem, it was per month, and so the exponent would be the number of months, which is 3. Whereas down here, for the second problem, we had our 1 minus 0.15, and that was per year, so then the exponent would be years. Okay, and again, try to keep things as simple as possible. All right. So for this first problem, you're borrowing $120,000 because you want to remodel the kitchen, right? And you're going to pay that off in 5 years, but you're going to be basing the loan on simple interest with a 6% annual interest rate. Okay, so the first thing we got to do is we got to get the interest. Okay, so we would do that. We would take the 120,000. Again, it's IP. Okay, and so then the rate would be based upon 6%, so 0.06, and annual interest rate means per year, so then the time would be years, and we would do that calculation. Okay, and now to find out how much we're going to have to pay back, we would add that to the 120,000, right? And then divide by the number of months in 5 years to find out how much we would pay back. Right? So that's how simple interest works. You get your interest first. You multiply the amount of the loan times the decimal rate, and then the time. And the time is based upon the rate. So since this was per year, then time would be years. That's the interest. We add that to the 120,000. That's how much we got to pay back. Since it's monthly, we're paying it back. In 5 years, 5 times 12 is the number of months. Right. You should get 2,600. Okay, so if you have compound interest, then it's a little more involved. Okay, so this car dealer offers this guy, Jim, the choice of 3 loans. And of course, the best loan would be the one where you pay the least amount of interest. The less interest you pay, that's a better deal for you. So if you assume you're ignorant and you were going to pick A, B, or C, think about what might entice you to pick A, B, or C. What would make you think, oh, that's a better deal, without doing any math? Just think about that. Just by looking at what you're seeing, and again, assume you're ignorant. Okay, let's go ahead and do the math. Okay, so now since we're talking about simple interest for the part A problem, first we got to get the interest. So we would do the 21,000, and then annual means that's per year, so 9%, 0.09, and then times 3. Okay, so with simple interest, that's it. That's all we got to do, because we just got to get the interest. Now, once we do the other two, we got to set up the equation based upon the compound interest here, right? And again, these are really the same. Okay, so for the fourth one, we're doing it monthly, instead of for the B one. And for the C one, we're doing it quarterly. Quarterly means 4 times a year, every 3 months. And monthly, of course, you know, that means 12 times a year. Okay, so we take our 21,000, we create a growth factor per month. So that would be 1 plus the 0.08 divided by 12. And then in 3 years, there would be 3 times 12 months. Okay, so we're basing this on monthly. So we need our rate to be per month. That's why we're dividing the per year by 12. And now the exponent is the time, which is months. So in 3 years, you'd have 3 times 12 months. Okay, I'm going to go to C, and then we'll finish these 2 problems. Okay, so we're the C one. Same thing. We start out with 21,000. Okay, now we need our growth factor. So 1 plus and 0.065, but this is quarterly, so we divide that by 4 to get our rate per quarter. Every 3 months, 4 times a year. And so in 4 years, you would have 4 times 4 quarters. Okay? Now, this isn't simple interest. So this includes the accumulation of interest added to the 21,000. So we're going to get a bigger number than 21,000 when we do this calculation, and this one too. Whereas this one just got us the interest. If we want to find out how much we pay back, we got to then add that to the 21,000. So if we're just looking for interest, the simple interest, we got it. B and C, we got to subtract to get the interest. Okay, so now you remember you're that guy, Jim, and you looked at the advertising that was provided by the car company who's more interested in making money. And you look at this 6.5% and you say, oh, wow, that's smaller than the other two. Well, that's probably a better deal. Oh, and look, I can pay it off a little longer. Is that true? Okay. As it turns out, this would be 5,670. This one would be 5,674, and I'm just going to ignore the decimals. And this one, the one that, based upon someone reasoning that, oh, that's a smaller percentage, and I get an extra year to pay it off, this one is actually 6,178. You got played, Jim. Right? So it's good to know that, right?